Hi guys, so I hope you all are doing well. So in my last video you may have noticed that I had explained you all about Euclid's division lemma, not algorithm, right? Well, this is Euclid's division algorithm. Okay, now how are the two different? Okay, so they seem a little confusing, and this is true because unless you understand the difference you would not know which one is which, right? So let me explain you the difference. Okay, so Euclid's division algorithm uses, okay, the formula of the lemma. See, A equals to B multiplied by Q, which is the quotient, plus the remainder. Once again, let me repeat. So Euclid's division algorithm is a way to find out HCF, highest common factor. If there are two numbers, say if we have 2 and 4, so what is the common factor between 2 and 4? So 2, isn't it? So whenever we find out the HCF, okay, using the lemma, Euclid's division lemma, which is a proven statement as I had told you in my last video, okay, we are able to settle with finding HCF, right, of any two positive numbers, integral positive numbers, integers. Okay, so this will become very clear, okay, if I will immediately do the sum before you. Now as per this we know that, okay, what do we know? That A equals to, A is one positive number, okay, where A is greater, okay, than B or even equal at times, okay. So A equals to B. B is the second integral or integer multiplied by the answer that you get whenever you divide this by this, okay, you get an answer, you get a quotient, don't you? And then some remainder, or sometimes may not be there if this is completely divisible by this, correct? If you divide 25 by 5, would you get any remainder? No, absolutely no. Okay, so we have over here, we are saying that we have to find out HCF of 196 and 42 using Euclid's division algorithm. So let's write, since we know that A 196 is greater than 42, so 196 here, and what is this? B, obviously 42. So what shall we get as answer? Okay, so when we divide 196 by 42, okay, what will be our quotient? Tell me guys. 4 times. This will go 4 times. Alright guys. And 4 times as in, this will go 168. 4 2s are 8 and 4 4s are 16. Right? We get a remainder, and what that remainder is 16, 8, carry 1 tha, so you're getting over here 2. This is our first remainder. So we write quotient here plus the remainder 28, correct? So this is very interesting, okay, that this one comes and takes the place here in the next step. This is step 1, this is step 2. So well, this one comes and takes a step here, okay, and again what is this to be divided with? So we have to divide by the remaining remainder. So if 42 was to be divided by 28, what shall we get? Let's do, because seeing is believing. 28, this goes 1 times, and what's the remainder guys? We have 4, 12 and 1 here, 14. So in the place of remainder we write 14 here plus here, and the quotient is 1. So we get quotient here, and what did we divide with? We divided by this 28. So 28 multiplied by 1. Correct? So this is very eventual, it comes one after another. Next step, bring 28 here. So, okay, now this remainder is going to divide 28. Alright, so I'm trying to underline or highlight it so that you know what we have to write here. So obviously this 14 will completely divide 28 by 2, right? 2 times, and we get a 0 over here. Now once having got a 0 remainder, okay, we know that what did, okay, led you to achieve a 0 remainder. So which number is important? In other words, let me explain you this very clearly. So since the last 0 remainder is 14, okay, this is a remainder which brought over here and led us to fetch a 0. We stop our procedure here. So this one is the non-zero remainder that brought us ultimately a 0 as the remainder. Okay, so what do we know from this is that the HCF of 196 and 42 is nothing but this number. Okay, so this is as simple as this. It's not complicated at all, just that these words may try to, okay, cause you a little confusion. Okay guys, so we'll come up with next, okay, interesting topic soon. If you have subscribed the channel, good. If you haven't, do subscribe the channel and keep the notifications on, okay, if you have already subscribed. Bye bye for now. Thank you.